we will start the new topic, electrostatics. Electrostatics means the charges are stationary, and electrodynamics, electrons are in motion or charge is in motion. So in electrostatics, we will study electrical force, electrical field, potential, capacitors, where the charges are not in motion. Now, the charge was first discovered by P.C. Thales of Miletus, Greece. He showed that when amber was rubbed by the silk cloth, then amber attracts the small strands and papers. So in the Greece, the amber means electron. So this phenomenon is given as electro. In this known as frictional electricity.
बोलो थोड़ा सा बोलो ना.
Other pairs are glass and fur. Similarly, plastic and silk. We study electrostatics. Electrostatic is a branch in which the charges are at rest, whereas electrodynamics a branch in which the charges are in motion. In electrostatics, we will study first electrical potential, electrical field, electrical force, capacitor, etc. For the first time, the charge was discovered by P.C. Thales of Miletus of Greece. When he studied the rubbing of amber with silk, he find that amber was attracting small pieces of paper and straw. In the Greece, amber means electron. So this branch is known as frictional electricity. In frictional electricity, we can have other pairs also, such as plastic and fur, glass and silk. If we rub plastic with fur or glass with the silk, then we will get the same effect as we have seen amber with the silk. When plastic is rubbed by the fur, then plastic becomes negatively charged and fur becomes positively charged. Whereas when the glass is rubbed with the silk, then glass becomes positively charged and silk with the negatively charged. The positive charge is equal to negative charge. Now, type of charges. There are two types of charges. One is positive and another is negative charge. The charge is a scalar quantity. Its SI unit is coulomb. Coulomb is a large unit and its small unit is microcoulomb, that is 10 raised to minus 6 coulomb. If we take a glass rod which is rubbed by silk, so the rod is positively charged. We take another glass rod which is also rubbed by the silk, that is also positively charged. If we put these two rods near each another, then there is a repulsion. It shows that the charge is similar of nature. Now if we take another plastic rod and which is rubbed by the fur or silk, then it gets negatively charged. If we put the glass rod with near the plastic rod, then there is a repulsion, there is an attraction. It shows that the similar charges are attracted or repelled. The similar charges are repelled and dissimilar charges are attracted. So, there are two types of charge. One is positive charge and another is negative charge. And it was said that the negative charge is due to the electron and positive charge is due to deficiency of electron. Now we know that the atom is made up of protons and electrons. Total charge on the atom is 0. The number of negative charge is equal to number of positive charge. When we rub the glass rod, before rubbing, the charge on the glass rod was 0. There was no charge. When we rub it, what will happen? The glass rod get positive charge. It means the electrons of the glass rod are transferred to the cell. Whereas in the glass rod there is a deficiency of electron, means its charge is positive. The charge on electron, charge on glass rod will be equal to the charge on the cell. So both the charges are equal in amount, but they are opposite in nature. If we recombine them or if we make the contact glass rod with the cell, then both are neutralized and net charge is equal to 0. Contact. Now if we take the two spheres which are in contact to each another and we bring a positively charged glass rod, then due to the positive charge, electrons will be attracted towards the positive charge. So there will be excess of positive charge in the B sphere and there will be excess of electron in the A. Now if we make a sum difference distance between A and B, then positive charge will be in B and negative charge will be A. Now we remove the glass rod, then A will be completely negatively charged, whereas B will be completely positively charged. So by contact A and B sphere, we can get two charges. A is positive, A is negatively charged and B is the positively charged. Now charges by induction. Now induction level, if we take the sphere A and we bring a positively charged near it, then the negative charge of electron will be towards the glass and positive charge will be away from it. Now we will make earth the other end of A and remove that glass plate. So now A will be completely positively charged, so negatively charged. The positive charge will go to the earth. In this way, by induction, we can make the charges. Now, what are the properties of the charges? First property of charge is additive property. Additive property. Additive property, it means that since the charge is a scalar quantity, then the total charge in the enclosure will be the scalar sum or algebraic sum of the charges. So total charge enclosed will be equal to Q will be equal to Q1 plus Q2 plus Q3 and so on. That is equal to summation of Qi. If the charges the charges may be positive, charges may be negative. So if the charges are suppose 0.1 microcoulomb minus 3 microcoulomb plus 4 microcoulomb plus 2 microcoulomb, then total charge will be equal to 3, 1 minus 3 plus 4 plus 2, that is equal to 4 microcoulomb. So total charge will be equal to 4. The second property of the charge is quantization of charge. Quantization of charge means क्या? The quantization of charge means the charge on any body is a integral multiple of charge of basic unit, and that basic unit is charge of electron. So the charge on the body Q will be equal to n times the charge of electron, that is equal to E. So n is integer. N is always a whole number. So the charge on any body will be integral multiple of the magnitude of charge of electron. Now second is conservation of charge. Conservation of charge means the charge cannot be destroyed or can be produced. The total charge of a system will be always constant. Means charge is conserved. Suppose we are having a system which is isolated, then total charge will be equal to a constant. We can explain like suppose there are 3 bodies Q1, Q2, Q3, and they are isolated from all the sides, and they are mixed, and so that there are the charge distribution changes Q1 dash, Q2 dash, Q3 dash. Then Q1 plus Q2 plus Q3 will be equal to Q1 dash plus Q2 dash plus Q3 dash. So sum of the charges before and after they will be always equal. So the charge is always conserved. We can also give the example of uranium 90 to uranium 235, when it decay to the thorium 90 plus alpha particle helium 24, then 231. Then here 92 is number of proton, that is number of positive charge before the reaction, and after the reaction thorium 90 and alpha particle 2. So 92 is equal to 90 plus 2. That is also we can say it is conserved. So before the reaction number of positive charge will be equal to number of positive after the reaction. Similarly, we can have the example of when proton changes to neutron plus positron plus neutrino. The charge on proton is 1, charge on neutron is 0, charge on positron is 1 and neutrino is 0. So 1 is equal to 1. So here also charge is. So in every nuclear reaction, the charge is always conserved. थोड़ी रेस्ट करो.